I'm delighted to have you as part of this community. Welcome, welcome, welcome. Welcome to our video on generalized forces. We're thrilled to have you here. In analytical mechanics, particularly Lagrangian mechanics, generalized forces are conjugate to generalized coordinates. They are obtained from the applied forces, acting on a system that has its configuration defined in terms of generalized coordinates. In the formulation of virtual work, each generalized force is the coefficient of the variation of a generalized coordinate. Let's now venture into the realm of virtual work and explore the fascinating intricacies it holds. Generalized forces can be obtained from the computation of the virtual work of the applied forces. The virtual work of the forces, acting on the particles, is given by delta W sum I mth Fi delta mth Ri, where is the virtual displacement of the particle. Brace yourselves for the next chapter, where we'll be dissecting generalized coordinates. Let the position vectors of each of the particles be a function of the generalized coordinates. Then the virtual displacements are given by a delta mth for I sum I germ frac partial mth Ri partial q j delta q quad I dots, and where is the virtual displacement of the generalized coordinate. The virtual work for the system of particles becomes delta W a math f ergitsum I germ frac partial mth R partial qj delta qj dots a math f ditsum I germ frac partial mth R n partial qj delta qj. Collect the coefficients of so that delta W sum I mth f I got frac partial mth R I partial q a delta q1 dots sum I mth f I got frac partial mth R I partial q ma delta qm. Get ready for an enlightening exploration as we dig into generalized forces and understand its role in the broader context. The virtual work of a system of particles can be written in the form alkic qm m, where qj sum I mth f I got frac partial mth Ri partial q quad gel dots m are called the generalized forces associated with the generalized coordinates. Now, let's dig deeper into velocity formulation and unveil the hidden treasures it holds within. In the application of the principle of virtual work, it is often convenient to obtain virtual displacements from the velocities of the system. For the n-particle system, let the velocity of each particle pi be, then the virtual displacement can also be written in the form a delta mth Ri sum I germ frac partial mth vi partial det qj delta q quad I dots n. This means that the generalized force can also be determined as qj sum I mth f I got frac partial mth vi partial det quad gel dots m. As we move forward, let's uncover the untold stories and fascinating intricacies of D'Alembert's principle. D'Alembert formulated the dynamics of a particle as the equilibrium of the applied forces with an inertia force apparent force, called D'Alembert's principle. The inertia force of a particle of mass is Fimei I1 n, where is the acceleration of the particle. If the configuration of the particle system depends on the generalized coordinates, then the generalized inertia force is given by qj sum I mth f I got frac partial mth vi partial det q quad gel dots m. D'Alembert's form of the principle of virtual work yields out qm qm m. Don't forget to hit that notification bell so you never miss an update from my channel.